the value of the vertical asymptote. This is going to be really important because later on you're going to be given some x values. So you need to know where the vertical asymptote is in relation to the two values that you've been given here for x. The last part, you've got to work out the total area. So this is the area underneath the curve. And you need to know that the area under the positive answer up here is going to be a positive answer. If you worked out the area under the curve where it's underneath, you get a negative answer. So it's really important you know that this part is going to be positive, this part is going to be negative. And because it says total area, you're likely to be both sides of this curve here because it says total area. And you've got to work out the total area between the curve, the x-axis, the line x equals 4.5 and x equals 7. But we don't know where 4.5 and 7 are on this graph initially. So we've got to work out where these two values will be in order to help us work out which areas we're trying to add together or which area we're finding. You must give your answer as exact form in the form A ln3 plus B ln2 plus C, where A, B and C are values that you need to work out. So you've got to state the values of A, B and C, and this is worth 4 marks in the exam. The key facts that we need to be able to answer this question. The word total area, okay, because it says total area, it means you are going to be looking at a positive area up here, and this is going to be a negative area on the left-hand side underneath the curve, so you're going to have to make that positive. So your total area is the area above the curve, which you can work out nice and easily, plus the area underneath the curve. But you've got to take the modulus of it. You've got to make that answer positive in order to be able to work out the total area. You also need to know what the word asymptote means. So this is a line that never reaches the curve. So it is really important for you to know where this vertical asymptote is so you can work out where these two values lie in relation to the asymptote. Press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Okay, great work. So as I said, we're concentrating on part C here, so this is the key bit of information we're going to be looking at. So I'm going to tell you that the vertical asymptote was at x equals 4. The reason it was at x equals 4 is because if you put 4 into this equation, 4 minus 4 is 0, and you can't take an answer of ln 0, which is why the answer is x equals 4 for 1 mark. Which means we can draw this asymptote in on the graph, which means the curve will never reach this line here at 4. This is called a vertical asymptote. This is a really key point because 4.5 has got to be bigger than this number, so it's got to be to the right of this line. So 4.5 could be anywhere along this line coming across here. So we've got to work out which side of this point of intersection with the x-axis 4.5 is going to lie, because that will affect how we work out our answer. Now, as I said earlier, because it says total area, I'm expecting 4.5 to lie on this side of the intersection point, but we're going to work through just to see whether that's true or it isn't. So first of all, we need to find this point of intersection. So this is where the curve crosses the x-axis, and to cross the x-axis, that means y is equal to 0. So our equation, ln of x minus 4 equals 0. To get rid of ln, I have to do the opposite. So the opposite to ln is e. So I've got to do e to the power of 0 is equal to x minus 4. Anything to the power of 0 is always 1. So 1 is going to equal x minus 4. To get rid of minus 4, I'm going to add it. So 1 plus 4 is 5. So this point here where they cross is the point 5. So that means we now can identify where 4.5 lies. So 4.5 obviously is going to lie between the 4 and the 5. So it's going to come in here. So you can see we have got a negative area going to be appearing in here where the red dot is, as we would expect because the question said total area. That means 7 is going to be somewhere over here to the right of that. So we've got to look at the integral of two separate areas. So one between 4.5 and 5 and one between 5 and 7. The answer between 5 and 7 will be positive because this is above the curve. And the answer between 4.5 and 5 will be negative because this is underneath the curve. So I've got to take my negative answer, make it positive, add that to the area between 5 and 7, and that will give me the total area. our total area is the integral between 5 and 4.5 of ln of x minus 4 dx, plus the integral between 7 and 5 of ln of x minus 4 dx. And that will give you 1 mark for identifying we need to integrate the same function between two different limits. So one is integrated between 4.5 and 5, and the second is integrated between 5 and 7. It covers the total range between 4.5 and 7, but just split it up because one is below the axis and one is above. Now we're going to use our answer to part A, because we're told that the integral of ln of x minus 4 is the same as x minus 4 ln of x minus 4 minus x plus c. Now because we've got limits, we don't need to worry about the plus c, so we can literally just replace the whole of this expression with x minus 4 ln of x minus 4 minus x. And I can put my limits at the end, so between 5 and 4.5 and between 7 and 5. Next, we then need to substitute in the values. So I can substitute in 5, which is the top limit first. So substitute for x to be 5, and then I'm going to substitute x to be 4.5, but I'm going to subtract the answer when I put in the 4.5. So it's the 5 one first, take away 4.5. Then I'm going to add on the answer for 7 substituted in, take away 5. Remember to put your modulus signs on here because we're going to have to make this answer here that will turn out to be negative. We need to make it positive. Press pause if you want to have a little bit of time to think about it and try and work it out ahead of where we're going. So we've substituted in the values, so we're going to substitute in the 5 instead of x, substitute in the 4.5, and again substitute in the 7, take away the 5 substituted in. You will note that the answer for this section here and the section down here are going to be exactly the same because these two functions here are going to be the same. This one's positive and this one's negative. And this will give you 1 mark for substituting in these values here. So if I just tidy it up, 5 take away 4 is 1, 5 take away 4 again is 1, the minus 5 just stays put on the end. 4.5 take away 4 is 0.5, 4.5 take away 4 again is 0.5 minus the 4.5. Substituting or simplifying, 7 minus 4 is 3, ln of 7 minus 4 again is 3, take away the 7 on the end. And this answer here is exactly the same as what we got earlier because these two functions are the same. So we're just going to take away this same answer. Now you should know that ln1 is 0. So this term becomes 0, minus 5. I can then multiply the bracket by the minus. So it becomes minus the first term. Minus times a minus becomes a positive. So I've got a plus 4.5. Remember, don't forget your modulus sign to make the answer positive. Then we've got the positive version of this bit here, so 3 ln 3 minus 7 is just positive, and then take away these two terms here. Again, ln1 is 0, so it's going to be take away 0, and the minus times the minus makes the positive. So from here, we now need to look at putting the terms together. So I've got negative 5 plus 4.5, which is going to give me minus 0.5. The minus 0.5 ln 0.5 just stays put. The 3 ln 3 is the same, and then I've got negative 7 plus 5 is negative 2. From here, I'm now going to get rid of this modulus sign, and I'm going to make everything positive. So I'm going to change the minus 0.5 to positive 0.5, and I'm going to change this minus 0.5 ln a half to be positive. At the same time as doing this, I'm going to look at the answer I'm trying to get. So I've got the answer to be in the form A ln 3 plus B ln 2 plus C. I've got the ln 3 here, 3 ln 3, so A is looking like it's going to be 3. But here I've got an ln 2, but I've got an ln of a half. So you should be thinking, well, actually a half is the same as 2 to the power of minus 1. So you could write a half as 2 to the minus 1. Taking the modulus here makes this positive and this term positive, so these are both positive. The last two terms have just stayed the same, and this is your third mark for working out that this is going to be made positive. From here we need to use the rules of logs, and the power comes to the front. So I end up with 3 ln 3. This power here comes to the front, becomes a minus 0.5 ln of 2. Then I've got negative 2 plus 0.5, which is minus 1.5, which is the same as minus 3 over 2. You can see this is very similar to what we've got in the question. So A is going to be 3, B is going to be minus 0.5, and C is going to be minus 3 over 2 or minus 1.5. And that will give us our fourth mark. Please have a big tick if you got this correct. Great work, well done. Here is the mark scheme for part A. We didn't go through this section, but you can have a look at it if you did try it to see where you went wrong and where you got the marks for. It is a show that question, so AG just means it is a show that question. The formula for parts is given in your formula book. Remember, if you've got an ln term to integrate, you need to let u equal the bit, which is the integral. So u is ln of x minus 4. So then you can differentiate this term, and then you have to let v dashed equal a magic 1. So this is 1 times a function. So you can integrate the 1 and you can differentiate this term, because you cannot integrate an ln function without using parts. Here's where the marks were awarded. M1s are method marks, A1s are answer marks, so you must be able to show your method as you're going along in order to be able to get the 5 marks for the question. So well done if you managed to try that and got that correct. Great work. The mark scheme on this bit says for part B, we just got to state x equals 4. Must be an equation to get the 1 mark. And the bit we're interested in here is part C. So you've got to show that it's a broken up integral sum. So you've got to split it between 5 and 7 and between 4.5 and 5 with your modular signs either side of the second integral, or as we did at the first integral. And that will give you 1 method mark. M1s are method marks, A1s are the answer marks. So then for substituting in those values for the area, a correct unsimplified equation gives you an answer mark. Then you get a method mark for trying to attempt to rearrange the equation. For using the ln a half is the same as minus ln2. That will give you a method mark. And your final answer mark comes for getting the answer correct. So you do need to make sure you've written down your answer nice and clearly. For marks, the question did say state the values of A, B and C, so it is always worth stating those values. The mark scheme here hasn't explicitly stated what A, B and C are. It's implied within the answer, but it's always worth stating A, B and C if it says to find the values of them. If you found this video useful, please share, like and subscribe so we can all get great at maths.